Hello and welcome to the video lecture on serial transmission in 8051 microcontroller. Here we are going to discuss one simple program in assembly language, and also I am going to show you how it works using keil software. Now first we will understand what are the different programming steps if we want to transfer the data serially in 8051 microcontroller. The first step is you have to load the tmod register with a particular value. So in this case it is 20h, because here we are using a timer 1 in mode 2 for setting the baud rate. Now we know that the baud rate value is set in the register th1 according to the calculations that I have already shown in my previous video. Now this is actually the tmod register. This is a format. This tmod register also I have explained in detail in my previous video. So all these links I will provide in the description box. So for detail you can go and check the videos. Now here in this tmod register, how to set this value or how the value will be 28. So let us understand that first. Here we are using a timer 1 in mode 2. So we are only focusing on these upper 4 bits as we are using the timer 1. So gate bit is always 0, that we know. C oblique T bar, that means here we are using it in a timer mode. So we are going to also put it equal to 0. And here we are using mode 2. So according to the table, this value will become 1 0. And here we are not dealing with timer 0. So I am going to put all these bits equal to 0. So the value will become 0010 and 0000, which is nothing but 28. So first you have to load the tmod register with the value 20h, indicating use of timer 1 in mode 2 for setting the baud rate. Now in our example, whatever we are going to discuss, I am going to set the baud rate value equal to 9600, and therefore according to this table I am going to use the value FD, and that value I am going to load in this TH1 register. Then the third step is now you have to format the SCON register, that is a serial control register. Now this serial control register is basically for indicating which serial mode we are using. So here we are programming in the serial mode 1, and this is the format of the SCON register. So let us understand how the value will become 50h from this format. Now the first two bits, that means this MSB bits SM0 and SM1, these two are called as a mode selection bits. So as here we are using a serial mode 1, I am going to make it equal to 0 and 1. This SM2 bit is mainly for multiprocessor communication. So here I am not interested. So let's put it equal to 0. REN enable, you have to make it 1 if you want to receive the data. So here I am going to make it equal to 1. TB8, RB8, both these bits, they are also used in the multiprocessor communication. So I am going to put it equal to 0. And TI and RI flags, these two flags I am initially making equal to 0, because whenever the transmission of 1 bytes get completed, the TI will become 1. Similarly, when the 1 byte is completely received, this RI flag will be 1. So initial condition of TI and RI will be equal to 0. So now if you check this value in the SCON register, it will become 50H. So I am going to load this SCON register with 50H, which indicates that we are using a serial mode 1. Now for setting the corresponding baud rate, that means we have already loaded the value in TH1 register. But for setting that baud rate, we have to start the timer, and therefore the next step is you have to set the TR1 bit equal to 1, which will start your timer for setting the baud rate. Then initially you have to make TI is equal to 0 by writing a clear TI instruction. Now whatever character you want to transmit, that you have to take into the SBUF register, because the SBUF register is nothing but it is a special function register used with a serial communication. And whenever you want to transmit any data, then that data must be present in the SBUF register before transmission, and whenever you receive the data, then the data must be present in the SBUF register after reception, and then you can pick up the data from SBUF. So mainly Here we are dealing with a transmission. So whatever data you want to transmit, first you have to take it into the SBUF register. So first step is you have to take the character byte into the SBUF register. And then you have to poll this TI flag, because what is the role of a TI? TI is nothing but it is a transmit interrupt. So whatever character you want to transmit, when the transmission will be complete, then at that point it is going to raise the TI flag. So I am using the instruction JNB, that means jump to this label if the bit not set. So not NB means not bit set. So which bit we are monitoring here? We are monitoring this TI bit. So initially I have set it equal to 0, but when my transmission of one character byte will complete, it is going to raise this TI or set this TI flag. So I am using the instruction JNB TI XX. XX is nothing but it is a label. And then lastly, to transfer to the next byte, you have to again follow the same procedure and repeat these steps from step number 5. So 5, 6, 7, these steps you have to repeat continuously for how many characters you want to transmit. So this is what is a simple procedure. Now let us understand one example and its demonstration using a keil software. So this is a problem statement. Write assembly program for 8051 to message yes serially at 9600 baud continuously. Use 8-bit data and one stop bit. That means we are using a asynchronous communication. Baud rate given is 9600 and I am going to transmit yes serially. Now let us first see the program and then we'll go for a step-by-step debugging of this same. Now see, let us first understand what is the logic that I have written for this program. So the first line is org000h. So this is the assembler directive. Then the first instruction is you have to load a tmod register with a 20h. So just now we have discussed. Then th1 value you have to load according to the baud rate. So baud rate we have set equal to 9600. So I will make it equal to FD. Then SCON register you have to set equal to 50. So that also we have discussed just now. Then you have to start the timer. So I will write a comment here. Here you start the timer. For what purpose? So for setting the baud rate. That is very important here. Now here I am going to transmit yes. So actually I have written a small routine over here. Separate routine is there. And I am using a call instruction. So using a call instruction, I am going to call this particular routine for each and every character. So first I have copied this y into the accumulator and then I have called the routine. So first I have moved y, then e, then s. Now we'll go to the debug section. And here one more important point is you have to set the frequency. So how to set the frequency? So go to target 1, option for target 1, and here you have to change the frequency. So it may be something different. So set it equal to 11.0592 megahertz. So just click on OK and then go to the debug section. Now we'll step by step I will debug this program so that you can understand it clearly. Here you need a timer and counter 1 window, a serial channel window, and this is a UART window. Here I am going to observe my output. That means here I am going to transmit the data serially, which I am going to observe on this UART window. Now for this purpose, what I will do is I will add one breakpoint here. So just insert one breakpoint here, and now we'll go step by step. Now here again first is you have to load the tmod with 20. So you can observe in the timer window when the instruction is executed, the 8-bit auto reload mode is indicated in the timer window and tmod is loaded with 20. Then this th1 value I have loaded equal to fd. So initially you can observe th1 and tl1 both are 0, but now after execution of this instruction the th1 will become equal to FD. So okay, previously I have loaded with FA, so just I will close and again take the window so that it will be loaded with FD. Okay, I think I have not saved this program. Just a minute. So just come out of the debug. This I have made this change, so save and again rebuild it. Yes, now it will work properly. Yes, so again let us continue. So 20, now TH1. Now see, TH1 will be now loaded with this FD. SCON will be loaded with 50. So now see the serial channel window. So here, see here, it is indicating the mode, that is the 8-bit UART mode it is indicating. And REN enable we have made, so it is selected in this box. And SBUF value presently it is equal to 0. Now if you can see in the timer window, the status of the timer is stop, and in the serial channel if you can see, the baud rate is still not set, it is 0. But when we execute the instruction set BTR1, what will happen? This status will change from stop to run, and at the same time you will see the selected baud rate in the serial channel window. So let us observe this. So see here, the status has changed to run and baud rate is set equal to 9600. Now this first character Y, first I will copy into the accumulator. But we know that this characters hexadecimal value of ASCII will be moved into the accumulator. So corresponding to Y you will get a value 59. And now I am going to call the routine. So when I give a call instruction, the control will be transferred to the routine. So now whatever value present in the accumulator will be copied into the SBUF, because then only you can transmit that particular character. So see here, accumulator contains 59, so SBUF also contains 59, which is corresponding to the letter Y. Now here we are going to keep on checking the TI flag. That means now unless and until this Y character has been transmitted completely, it will be on the same instruction, and when it will become transmission will be complete, then only it will come out of the loop. So just I will use this. Now see here, you can observe, so the transmission of Y is complete, so it has come out of the routine, and now it is the control will be passed to the next instruction, move A comma E. So again E will be now copied into the accumulator. So the hexadecimal value, ASCII value of E is 45. So that will be copied. Again the routine will be called. Now that value will be copied into the SBUF. So see here, again 45 will be copied into the SBUF, and again poll the TI. So see here, so when this is executed, then E will be transmitted. Now control will be passed to the next instruction. So now it will go for S. Value will be copied, will be passed to the accumulator. Again call the routine. From accumulator it will go to the SBUF. So SBUF will contain 53. Again it keep on polling the TI, and when it will complete the transmission, the complete will be, and this process will continue. Now what I will do, I will simply remove this breakpoint here, and I will simply run the program. So you can see here, here is the output YES YES. So it is continuously transmitting on the UART window. So this is what all about the serial communication transmission program. So if you like my video, then please subscribe to my channel and share the video with your friends. Thank you guys. Thank you so much.